Flu viruses are quick change artists. They constantly mutate, and those frequent changes make it hard for our bodies to recognize and fend off the virus. That's why we need a new flu vaccine every year. The outside of influenza A viruses are studded with two proteins called hemagglutinin and neuraminidase. There are many versions of these proteins. The combinations of each H and N give flu its name, like with the common H3N2 and H1N1 viruses that are part of every year's flu vaccine. Hemagglutinin helps the virus attach to cells in the nose, throat, or lungs, key to getting infected. If the immune system recognizes a particular hemagglutinin from either an earlier infection or vaccination, it will produce flu-fighting antibodies to block the virus from latching on. As influenza virus spreads, it gradually undergoes subtle genetic mutations. Eventually, with enough changes, defenses the body built in the past can no longer recognize current strains. That's called antigenic drift, and it's why the flu vaccine gets an annual update. But every so often, influenza undergoes a sudden, major genetic change, resulting in a flu strain so different that most people have little or no immunity, like during the 1918 Spanish flu pandemic. Pandemics can happen if a virus carried by a bird or a pig mixes and swaps genetic material with a typically human strain, infecting people with a novel virus. That's called an antigenic shift. Sometimes an animal strain jumps directly into a human. Global health experts decide the recipe for each year's flu vaccine based on predictions of which strains are most likely to be spreading the following winter, and hope the flu doesn't drift enough that season to spoil the match. Seasonal flu vaccines won't protect people in a pandemic. Now scientists are working to create a universal vaccine that might one day protect against both kinds of flu evolution.